Welcome to the channel Science Geek. Hope the dear students and the subscribers that you have seen my previous videos of biology. So just to give a twist to Science Geek, I have now made a video on a lesson of chemistry, class 10, a very important lesson, acid, base and salt. Now this lesson, acid, base and salt, was read by all the students in their junior classes, that is class 7, where you can just recap that what you read there. Okay, so related to that, in this class 10, what you will read in this lesson, first the outline of the things in terms of LMR, last minute revision. What are acids? What are the properties of acids? What are base? What are the properties of base? And in the end will be the salts and the different types of salt. In between will be pH and the universal indicator. Now, you must have read in your junior classes about indicators, especially the litmus as an indicator, which was obtained from lichens, plant which we see in the nature by the symbiotic relation of an algae and a fungi, which is known by the word lichens. And these lichens are the source of litmus, okay, natural indicator. So now to start with the lesson, acid, base and salt. First thing here, we will read about the acids, as I said, the properties of acids, and then in this video especially, I will tell you about acids. In my next video, it will be about base, and the third video will be about salt. So now to start with acids. Now whether it is an acid or a base, they are chemical substances. Now these chemical substances are having two origins. First, if they ask you, what is the origin for the chemical substances which you see? So the answer for this will be obtained either from the animals or the plants, that they are called as organic acids, and if they are obtained from mineral rocks, they are called as inorganic acids. So acids basically two types, organic, inorganic. Second thing, how to differentiate between an acid and a base. Right from the junior classes, you have read about the word litmus. Now this litmus is of two types, the red litmus and the blue litmus. Now, this red litmus, again, you recapitulate, it shows no change in an acidic solution, but the blue litmus becomes red in an acidic solution. The experiment can be done with HCl in a test tube, and you take the litmus paper and see the changes. For base, you can do the changes with NaOH. Even in your practical, this experiment is there to study an acid and a base and to study the differences in terms of the litmus. So, that is the natural indicator litmus. First thing in your mind, the role of litmus in an acidic solution. Here, that is red litmus and blue litmus. Okay. Then comes the two synthetic indicators which you will keep in mind, the phenolphthalein and the methyl orange. This again are known as synthetic indicators because when we will test them for the neutral solution, acidic solution and basic solution, their colors will be different. Now this is a small table which you should also prepare and keep in your mind. Litmus in neutral condition is purple in color, that is its original color. In acidic condition it is red, and in basic condition it is blue. It depends upon which kind of litmus paper it is. Red remains red, but the blue becomes red in an acidic solution. Okay? Phenolphthalein. Phenolphthalein is colorless in a neutral solution. It is also colorless in an acidic solution, but becomes pink in base. That is sodium hydroxide. This experiment was there in 7th standard when we take HCl and we pour NaOH into it and see the changes in color, because HCl and NaOH is the best example of neutralization reaction. Acid plus base to give rise to salt and water. There the use of phenolphthalein was done to see the changes. So methyl orange in neutral solution is orange in color, in acidic it is red in color, and again in basic it is yellow in color. So you remember this chart for if they ask you another question, compare litmus, phenolphthalein and methyl orange in acidic, neutral and basic solution. You can give this chart there last minute. Next, another kind of indicators which this question is frequently asked, what are olfactory indicators? The indicators which can be sensed with smell. Now which all indicators are there? Onion is there, vanilla is there, and clove oil is there. This onion, vanilla and clove oil, they also show their changes in colors in basic and acidic solution. Now this onion for example, it has a characteristic smell in HCl or acidic solution, but it doesn't have any smell in a basic solution. Same as for vanilla, characteristic smell in acidic but no smell in basic. This is also given, an activity is given in your NCERT book to check which indicators react with which kind of substances there. Activity is given there. So please see that activity, and they can give you various types of acidic substances like vinegar, lemon juice, HCl, acetic acid, depending upon the strength of the acid. And we are talking about acids now, so I am only concentrating on olfactory indicators with acidic solution. And base, they can give you soap solution, shampoo, others, sodium hydroxide, and how do they affect. So till now you just came across acids. First property told you, sour in nature. How to test whether the acid will show changes in indicators, the role of litmus, red litmus, blue litmus. What about natural? There are natural indicators, synthetic indicators, phenolphthalein and methyl orange. Olfactory indicators, onion, vanilla, clove oil. Now this was the last minute point about the indicator part of acids. Now we come to the another part where we will see the main reactions, how the acids undergo the reactions, where you have to study about the properties, okay, the properties of acids. The first property which we will study here will be the properties of acids. Acid, it will be any acid. Acid plus metal. The reaction of metals and acid will give rise to what? Salt plus hydrogen. Write all the reactions in boxes. This is the skeletal reaction. Now that acid can be, I can take that acid to be as H2SO4. Always write the state, aqueous, plus zinc, that is the zinc granules, giving rise to ZnSO4 plus H2 gas. Okay, again this is aqueous. Board exam requires the state to be written in brackets. You should write that. This is the first example. Second one will be, I give you of the same Zn, that is solid, plus HCl, aqueous, gives rise to ZnCl2 aqueous plus hydrogen. Okay, this is a very very important reaction of acids with metals. They can ask you to write various metals and their reactions, but the best example is that of zinc, given in your NCERT book. With this, there is one figure in your book which you should keep in mind. I am not drawing that figure here. That figure tells you about how that acid is tested. It is there in your practical. They can ask you to draw that whole experiment. Keep in mind that to show the test of hydrogen. How to show the test of hydrogen in this case. So this experiment, a simple diagram is there. All diagrams should be drawn in boxes. Where you will, that test tube is there, if you see, zinc granules will be there, and HCl will be there, and whatever hydrogen gas is evolving, it is allowed to pass in another container where we put little soap solution, bubbles come out, and we bring a matchstick here, and a pop sound. And a pop sound comes. This pop sound tells you about the evolution of hydrogen gas. This is a very very important reaction to show that hydrogen gas is produced by the action of acid on zinc passed in in a soap solution, and by bringing a burning splinter near it, a pop sound is produced. Now this question is often asked in board exam if they give you four metals like magnesium, zinc, iron, copper. Again, this is a very frequently asked question, that which metal will react with hydrogen, which metal will react with acid and evolve hydrogen very fast. That depends upon the reactivity series, and this reactivity series of metals will be read in the lesson metal non-metal. So according to the reactivity of that particular metal, the reaction takes place with that particular acid. So if you will see, the hydrogen gas will be produced maximum in the first case in magnesium, then zinc, then iron, and least in copper. In copper we can say negligible, no reaction takes place. So you should keep in mind this, for example, magnesium, zinc and iron and copper, which metal reacts with the acid first and where the hydrogen evolution takes place very fast. So this was the first property, acid plus metal gives rise to salt and hydrogen. Next property, metal carbonates and bicarbonates. The reaction of metal bicarbonates and carbonates. How with acids? Now first one is Na2CO3 plus H2SO4 giving rise to Na2SO4 plus H2O plus CO2. You should write the names of this compound here, which I am not writing. General reaction will be metal carbonates or bicarbonates. They react with acid to form salt plus CO2 plus water. Put it in a box. Put this reaction in a box. Like the first one you read, salt and metal and acid gives rise to salt and hydrogen. Here which gas is evolved? Carbon dioxide. Metal carbonates, which is Na2CO3, or metal bicarbonate, that is NaSCO3, can react with an acid to give salt, carbon dioxide and water. Very, very important reaction, and the example is given in your book. And also the importance of this reaction of acids with bicarbonate is that if a person is suffering from acidity due to overeating or indigestion and a pinch of baking soda is given, then that acidity is neutralized. So that is the importance of this particular reaction. Now, how will you test the presence of carbon dioxide? How will we test that CO2 is evolved? For this, what we do is, another reaction is given in your book. Na2CO3, I will write the reaction, that will be a separate reaction here. So keep in mind this reaction, sodium bicarbonate with sulfuric acid, sodium bicarbonate with HCl. Now that, and this is the A part, this is the general reaction. Now the B part, I write here Na2CO3 plus HCl, which is given in your book, I believe, 2 HCl, giving rise to 2 NaCl plus H2O plus CO2. Now, to test the presence of CO2, this CO2 is passed to lime water, that is calcium hydroxide, COH twice, plus CO2 gives rise to CaCO3 solid plus water. Put it in a box. To test that CO2 has evolved, CO2 should be passed through calcium hydroxide, calcium carbonate, insoluble, that precipitate, and H2O is passed. H2O is produced. Now, if excess of CO2 is passed through this same thing, this precipitate will disappear. That is, the CO2 if passed through live water disappears when the soluble bicarbonate, calcium bicarbonate is formed. For that, this same reaction can be CaCO3 plus H2O plus CO2. This is insoluble. Remember, this is insoluble. Gives rise to CS calcium CH3 twice aqueous. This is soluble one. That is, this is a soluble one. If they ask you in exam that write the reaction for how calcium carbonate is produced in the first step, what happens to that calcium carbonate when excess of CO2 is given to it, what product is formed there, and this they can ask you in terms of A and B. That they will just change the name, right? They will change the name. Give the reaction of any metal carbonate or bicarbonate with acid, show the products formed there, how to test the nature of that product formed there, what product is formed there, how it can be tested, and name that product. So this all question will be of 5 marks. So I think it is now on your fingertips. This one, first one was metal plus acid, salt and hydrogen. To test hydrogen, burning splinter. This one was metal carbonate or bicarbonate with any acid. Okay, now the next reaction which I want to tell you here will be about metal oxides. All metal oxides react with acid to form salt and water. Common feature. What do the all acids contain? Say if you write, if I write HCl, I write H2SO4, I write HNO3. So what do you see here? What is the most common feature that all acids contain? All acids contain one particular thing common here: hydrogen, hydrogen, hydrogen. This is the common thing in all the acids, right? First thing. Second thing, all these acids do is they conduct electricity. Now, you must have read how electricity is conducted. It is conducted because of ions. And these ions, they travel in the circuit, and that makes that solution a conductor, and we call it as an electrolyte. So, the common feature for all the acids are some acids are very strong electrolyte, some acids are very weak electrolytes, and some acids don't act only as an electrolyte. For you to keep in mind, all acids contain hydrogen as common. All acids conduct electricity because of ions, and these ions conduct electricity, and the acidic condition of that particular solution depends upon the strength of that ion, that how far that acid can break up into ions. Say for example, this is another important thing, that an acid can break, like hydrochloric acid, it dissociates into ions H plus Cl minus, H plus Cl minus. This H plus which we see here is also known as hydronium ions because it can combine with any number of water molecules to form H3O plus. So this H plus or H3O plus is one and the same. So that's why when we say we want to dilute an acid, acid is added to water. Water is not added to acid. Acid is added to water. Water is not added to acid. Very, very important. And for this, we say that we are diluting the acid. When we dilute the acid, the per unit volume of hydrogen decreases there. And so, if the hydrogen volume is decreasing there, the amount of hydrogen evolution will also be affected. So, the significance of this reaction is that when an acid breaks into ions, the ions are known as hydronium ions, H plus. This H plus can combine with any number of water molecules there to form H3O plus, and this H3O plus it shows that the acid is having a strong character if the hydronium ions formed there can act as an electrolyte, and can act, all acids as I said don't act as an electrolyte. So acetic acid cannot act as an electrolyte as compared to H2SO4. Some are very strong acids and some are weak acids. Okay, so as per this we can say acids are the substances which contain hydrogen and which when dissolved in water gives rise to H plus ions in the solution. And this is very important. Okay, and to see this was the last part of this video. The properties of an acid are due to the H plus ions or hydronium ions in an aqueous solution. And this dissociation of an acid into its two parts, H plus and Cl minus, is known as ionization. What it is called? It is known as ionization. So I will not tell you much here. Continue with the basic part. I end the video here with the acidic part, that is what are acids, the properties of acids, what are indicators, what are natural indicators, what are synthetic indicators, differences in acid and base, then the properties of acid I taught, the properties of an acid with all the reactions, the basic reactions, and in the last part of the lesson was acid, the common feature, hydronium ion, the role of hydronium ion, and what is ionization. For just the definition for you will be this things which I just told you. I hope this the first part of the video which is clear to you. Till then, read it, subscribe it, and stay geeky. We'll meet in the next video with base. Thank you.